Hi y'all. Today we'll talk about plasma treatment of fabrics. So big shout out to Win32 JPEG. First for commenting on the video. Second for having a really awesome handle, Win32 JPEG. That's cool. That takes me back a bit. So Win32 JPEG writes, "Hello Greg. This was an interesting video referring to the what is plasma video. Is there any chance you could make a video explaining more about the usage of plasma for clothing, like you had mentioned?" Well, sure. I did a lot of work on plasma treatment of various fabrics and fabric-like materials, but I'll try to simplify it and put it in a more YouTube-friendly format. So let me tell you something crazy. The shirt that you're wearing, unless it's high quality natural cotton, or maybe you traveled to India and picked up some silk shirts, or Japan, if it's a normal shirt like this one, it's most likely been plasma treated. A lot of things, a lot of fabrics, probably almost everything you're wearing, your shoes, your socks, your shirt, especially more advanced fabrics like all the stuff you take with you to the gym, most of that stuff has been plasma treated. Fake leather in your car, all of that stuff. Why plasma? There's no heat, no chemical baths, no visible change, no damage to the fabric, and it's done really, really fast. You know, plasma is just ionized gas. I just recorded a video about it. Basically, you generate plasma between two electrodes, and you can stick things into plasma, for example, fabric. It's just ionized gas. So plasma, this ionized gas, ionizes the fabric, modifies it on nanometer, on atomic scale, and makes it wettable, makes it much more easier to paint, to color, to attach things to, like antimicrobial chemicals. And that's why today we use plasmas for a lot of surface deposition and surface modification processes. You know, most of fabrics today, they're polyester, polypropylene, nylon. They're all hydrophobic. Tangent? You know, for the life of me, I kept on confusing hydrophilic and hydrophobic. And this might be really simple, but it really helps me. Hydro is water. Phobic, well, if a material has phobia to water, it's hydrophobic. It's afraid of it. So water doesn't stick to it very well. And hydrophilic, water. I lived for over 20 years in Philadelphia. Philadelphia, city of brotherly love. So phila is love. So something that loves water is hydrophilic. Well, anyway, nylon's hydrophobic. And another tangent. You know this little company DuPont? So originally DuPont is famous for two things: dynamite and nylon. Both were developed for military purposes originally, and dynamite is still largely used for military. Duh. But nylon, originally, it was, to the best of my knowledge, it was developed for parachutes. Really strong, lightweight material, you know, packs into a nice backpack, and it's used for parachutes. But nylon is like baby puke brown. Whatever that color is, like natural nylon color, is not very attractive. It's also really easy to see against the nice blue sky, right? So you have these paratroopers coming down, and they're all underneath this canopy of baby puke brown. So DuPont needed to develop a process, and quickly develop a process, to bleach nylon. And they used highly reactive, wet acid chemistry and bleach to literally make those nylon white or semi-transparent. And it worked really well. But after the war, nobody needs parachutes in those quantities, and DuPont got the nylon process going really well. So DuPont started producing nylons, the stockings for girls, and the business just boom, took off. Anyway, back to hydrophobic polymers. So if you want to color them or attach something to them, most of the old ancient processes use tons of water, lots of acid, heat. I mean, very messy, dangerous, OSHA nightmare, like the occupational health, big trouble in those days. Well, here comes plasma. You have this thing that you can turn on and off in a matter of a microsecond. It's highly reactive. Plasma helps you with surface activation. In air, you will add, you have polymer surface. So a lot of carbon-hydrogen bonds sitting on the surface. And air plasma will add hydroxyl radicals, for example, the OH groups, carboxyl groups like COOH groups and carbonyl groups. So CO groups, all of those are very hydrophilic. They really like attaching to water. And if that water is carrying a dye can covalently bond, so just permanently glue to the fabric. Plasma can penetrate deep into the fabric at atmospheric pressure. Kind of the limit has to do with so-called Debye radius. It's how fast electrons fly before they can ionize another molecule. But generally speaking, it's about 100 micrometers. So if your fabric is somewhat porous, like this here shirt or this t-shirt, then plasma treating them uniformly and all throughout the fabric is pretty relatively easy, given, modern technology developments. So you can paint this fabric right after plasma treatment. You can add functionality. As you're plasma treating or after you plasma treated, you can add various substances to the fabric. For example, we did some work with covalently bonding or gluing vancomycin, which is an antibiotic, and attaching it to the surface, so the surface becomes permanently antimicrobial because there is an antibiotic embedded into the surface. So if bacteria sits, breaks down and dies. So you can have really cool things. Another total tangent, not fabrics, but I stumbled into this technology and it's just absolutely amazing. Talking about plasma coatings. When you take a chocolate bar and grab it with your fingers, start eating the chocolate bar, well, the chocolate melts onto your fingers. And it's gross and it's sticky and it's brown and you have to, I guess, lick your fingers. If you're not a gentleman and if you gotta go find a bathroom and wash your hands, it's just messy. The plasma treatments are industrialized at this point. We have large-scale corona treaters. We have large-scale dielectric barrier discharge systems, various kinds of plasma jets, surface discharges, asymmetric dielectric barrier discharges, all sorts of stuff. This is developing fast. Yes, lots of things already solved, but if you can treat the t-shirt 20% faster, well, then you maybe can produce 20% more t-shirts, and then the price per t-shirt goes down by 20%, so your profit can jump up significantly. Lots of development is happening in this area, not to mention. I mean, Win32 JPEG, you asked about fabrics. A lot more work in this direction is going on in microelectronics and films, so treatment of polymer films for mostly microelectronic applications. There's clothing, all sorts of clothing, antimicrobial socks, flame retardant uniforms, medical dressings like for wound care or gowns or, masks that you wear during COVID-19 pandemic that kill the virus because of the coating on the mask. There's all sorts of applications, and all of them are low water, they're atmospheric pressure, they're fast, and they have many other advantages that are constantly being developed. Lots of publications that I see coming out every month in this direction. So, kind of to summarize why is plasma treatment so good? Well, you create reactive environment. this reactive environment, these days, through a lot of achievements in science and engineering, and a lot of SBIR grants too, so please bring the program back up. We needed to develop new solutions. But anyway, reactive, uniform systems, it's dry processing, unless you purposely add some kind of chemistry into your plasma. Plasmas can be very, very specific. So you can make surfaces hydrophobic, you can make them hydrophilic. Well, I got that backwards. I mean, polymer surfaces are normally hydrophobic. You can make them hydrophilic, but you can also take hydrophilic surfaces and make them hydrophobic. You can do a lot of interesting chemistries with fabrics and other surfaces, and you do it with virtually no residual chemistry. So a lot of plasma treatment, a week or a month down the road, the effects of plasma are completely gone. It's just the chemistry you added. So there is none of these reactive craziness that sticks around. It disappears pretty quickly. So next time you're heading to the gym, you put on your super Nikes, plasma treated. You put on your antimicrobial breathable socks, plasma treated. You put on your nylon stretchable, really cool shirt that you laundered 500 times and the logo is still attached, plasma treated. Anyway, Win32 JPEG, thanks for an awesome question. If y'all have any interesting or relevant questions that I can attempt to answer, please leave them in the comment section. I love doing this. I enjoy doing this. And I hope you enjoy watching and listening to this. Peace, y'all. See you in the next one.